Question 3, we're told that fx here, which is x plus tan x over 2, has a single root alpha in the interval that they're specifying. And in part A, we're supposed to show that this root lies between the interval 3.6 and 3.7. So just before we start, I like to convert back to degrees just so that it gives me a sort of a bedrock on which to work, and this is 270 degrees. Now, tan is a bit of an awkward function. It can produce a non-continuous function, and this proof of an interval where we're going to substitute 3.6 and 3.7 into fx prove, hopefully, there is a sign change, but we have to make the assumption that the curve between these 2 points is continuous. So with that assumption in mind, let's do those substitutions and see how we get on. So there's my substitution, and if you look that up on a calculator, you get the answer of negative 0.6862. And on it goes. Now substitute 3.7, and you get the answer, 0.2119. And you can see we do have a sign change of the function's value, which means the function must go through 0. So there's a very small diagram of the situation. I'm not saying the curve has this shape at all, but at least we do know that it must cross the axis between 3.6, coming up from negative and going positive at 3.7. So that's the answer to part A. And for part B, we have to differentiate f of x. So we can differentiate both of these terms separately. The first one is easy. This differentiates to 1. Now, if this was just tan x, this would differentiate to sec squared x. But we've got to use the chain rule. Yes, we're going to get sec squared x over 2, but we have to differentiate x over 2 as well. So the differential of x over 2 is a half, and this is going to be sec squared x over 2. And that's the answer to part B. So in part C, we're going to be using the Newton-Raphson method to find the root alpha. So we're going to be using our differential of fx as well as fx itself. So the Newton-Raphson formula is this, where xn initially is our first value of our root alpha. We're going to use this as 3.7. So we're going to be putting 3.7 into all of these positions, get a new value, which in fact will be the answer to the question because they only need us to use this method once. So I'm going to use my value of x1. This will produce me x2, so this is going to be equal to 3.7 minus, well, we've done this calculation already because we've already put 3.7 into f of x, so I can just write down this, which is 0.2119. And again, using a calculator, if I put 3.7 as the value of x into here, I'll get an answer of 7.5832. And this will generate a new value of x, our root alpha, and it's come up with 3.6720. So x2 to 3 decimal places is 3.672, and that will be the answer to part C of question 3.